Hi, and welcome to the Frog Pond School of Design, where we talk about a wide variety of architectural issues and hope to have a good time doing it. Something you may not have thought a lot about, but it's very important in the architecture of tall buildings, is the fact that those extremely tall buildings tend to sway in the breeze. This often happens, it's typically the building is moving in its own resonant frequency, much like a guitar string. The difference is this building is much larger, so the movement is slower and wider than with a guitar string. But that's really what's happening. The people inside the building can often feel this movement, but even if they don't, that wouldn't keep it from giving them a good old case of motion sickness. And we don't want our buildings making our people sick. So what do we do about this? Well, the problem has been known for as long as there have been tall buildings, and they've tried a variety of different solutions. One initially involved tanks of water, which they called slosh tanks, so that the water would move around and help dampen the movement of the building. They later moved on to large weights that were like train cars on tracks that could move back and forth. So all of these methods were intended to counter the movement of the building and kind of dampen the whole situation. Today, the emphasis is on having greater control over this, and they call these tuned mass dampers. And there's one in a building in Taipei. This building's 101 stories tall, so they call it the Taipei 101 building. And it's not a terribly broad building, but it's 1,667 feet tall, which is like about a third taller than our Empire State Building. So you can imagine the tendency of that building to move. Well, what they've installed in that building is a tuned mass damper. It is an 18-foot diameter sphere that weighs in at an astounding 728 tons. And it's suspended between the 87th and 92nd floor of the building. And it looks, a little closer view here, you can see it's suspended from cables, and down below its movement is controlled by hydraulic cylinders. So this is the tuning mechanism by which they try to make this ball do what it needs to do to best dampen the movement of the building. What it really needs to do is move counter to the building's movements so that it has a more effective dampening effect. A few years ago, this building took a hit from a direct hit from a typhoon. Now we're talking sustained winds of 100 miles an hour or more, some of them up to probably 145 is the best estimate there, and the building did pretty well. So the effectiveness of these devices has been proven. They're hoping they may be effective with earthquakes as well, but we'll know more about that in time. These things on a smaller scale actually have been used in boats and airplanes and that sort of thing. But the main purpose of them is tall buildings. And that's a science that continues to progress. I'm sure we're going to see these things advance more in the future as our buildings get taller. Another time in this series, I want to talk about just how tall some of those buildings are getting to be today and in the future. So the market for tuned mass dampers and whatever improvements come to them in the future is really going to continue. So thanks for joining us today at the Frog Pond School of Design. If you have any questions or other topics you'd like me to discuss, drop a note down below and I'll see what I can do. And I look forward to seeing you hanging around the pond again real soon.